In this problem, we want to find the binding energy and the binding energy per nucleon for an aluminum 27 isotope. And so we're given some values up here: the mass of an aluminum atom, the mass of a hydrogen, the mass of a neutron here. And so what's going to be true is that the mass of this stable isotope is less massive than the parts that make it up. So if we have an aluminum atom, we have 13 protons along with those 13 electrons. So what I'm going to do is I'm going to do 13 times the mass of a hydrogen. Why hydrogen? Well, because hydrogen is just one proton and one electron. So 13 times the mass of a hydrogen. These masses are in unified atomic mass unit. All right, so those 13 hydrogens plus the 14 neutrons, because 27 minus 13 is 14 neutrons. So 14 times the mass of a neutron, 1.008665 U. That would be the total mass of all the pieces. Now from that, I want to subtract the mass of the aluminum atom itself. And so what we're doing here is we're finding the difference in the mass. So 13, this might take me a moment to get it all typed in my calculator with all these decimal places. All right, so plus the 14 times the mass of the neutron, and then minus the stable atom itself. All right, so that's a difference of 0.241496 U. Now what we want to do with that is take that difference in mass and multiply it by what a U is equivalent to. 1 U is equivalent to 931.5 million electron volts per C squared. So if we multiply this times 931.5 mega electron volts per C squared, getting this calculation, all right, we get a binding energy of 224.95 mega electron volts. Side note, what I didn't show here was really when we're calculating energy, we're doing MC squared. I was showing M here because we're multiplying also by C squared. That's where these C squareds were canceling out, but I failed to show that a minute ago. Now, we want the binding energy per nucleon. So we're going to take that answer. We're going to divide it by, well, there's 27 nucleons because that's the mass number here. So divided by 27, we get a value of 8.33 mega electron volts per nucleon. So two answers: the total binding energy and the binding energy per nucleon.